All right, so drawing an angle in standard position has to do with starting with the initial ray on the positive x-axis and rotating the angle around. Remember, this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Those are our quadrantal angles. So if I'm going to rotate 35 degrees, halfway between 0 and 90 is 45, so I'm going to go a little bit less than halfway. That's this angle here is 35 degrees. Okay, 240. So if 180 is here and 270 is here, that means that I have my initial ray and I am going to rotate all the way around closer to 270. So this angle here, the rotation is more than 180 degrees, so that's a 240 degree angle. So the terminal side, so we have on an angle, we have the initial side and the terminal side, and the theta is in between. This terminal angle was in quadrant 1. This terminal angle was in quadrant 3. 315 degrees if this is a 270. And this, when you come back around, is not only 0 degrees, but it's 360 degrees. That's one full rotation. So 315, if we start with our initial ray, we're going to go past 270, and we're going to be over here somewhere. This would be my 315 degree angle, so the terminal side is in quadrant 4. Okay, now the reference angle has to do with reference angle is less than 90 degrees, but it can be any quadrant, okay? So, and also it should be less than pi over 2, because now it looks like we're starting to get into radians, okay? So 2 pi over 3. So let's talk about that for a second. So this is 0. It's 0 pi, okay? This over here, where normally 180 degrees is pi, because 180 degrees is equal to pi, and the unit on that is radians. Okay, so that's in a unit rate. So if I have 2/3 pi, that's not quite 1 pi, so we can call that 1 pi. So we are 2/3 of the way. Well, this is halfway, and so 2/3 of the way, whoops, didn't mean to erase that. Here's my initial side, 2/3 of the way. If you can picture this, here's 1/3, here's 2/3, and here's 3/3, or 1. So we're going to say that the rotation of 2/3 pi, here's 2 pi over 3 right here. That's the rotation of the angle. But the problem is we want to draw the reference angle. Well, the reference angle is less than a half pi, and it goes to the 90 degree, or to the x-axis. So this right here, this is my reference angle. Okay, and the way that we do that is we find the difference to the nearest x-axis. So this is to pi, and I've already gone 2/3 pi. So if I take 1 pi minus 2/3 pi, I'm left with 1/3 pi, or pi over 3. So the reference angle is pi over 3. Okay, for 225, I should say. So now I got to decide. Now I'm in degrees, 180 and 270. So I have to go 225 degrees. So here's my initial, and I'm going to rotate around past 180, and I'm down here. This is 225 degrees. We are going to the x-axis. So the closest x-axis is right here. That's my reference angle. Okay, so I will subtract the 225 minus the 180, and I get a 45-degree angle as my reference angle. Okay, for 330 degrees, again, here's 270, and here's 360. So I am going to rotate around past 270. 330 is pretty close to 360. So this is the 330 degree. And I'm going to go to the x-axis. So this is my RA. That's my reference angle right here. And so how do I get there? Subtract to the nearest x-axis value. So 360 minus 330. I get 30 degrees, so the reference angle is 30 degrees.